And we're back. So right here, the blank right here, I don't understand the purpose of this because the answer's right here. So I'm just going to give it to you. An auxiliary line is sometimes useful when solving for unknown angles. So you're going to have to forgive my pronunciation of auxiliary because I have an articulation disorder with the letter L for certain parts of it. So I'm going to mess that up. So it is what it is. So in this figure, we can use the auxiliary line. We can use the aux line, past that aux cable. We can use the aux line to find the measures of E and F, of angles E and F. And then add the two measures together to find the angle of W. What is the measure of W? So what you might notice here is that you've got this little dotted line going on. So this little dotted line is basically saying that this didn't exist originally, so we drew our own line that we defined to be parallel with these two. Notice we've got that. We've drawn that line at that vertex of that angle, and we have said we don't actually even need a diagram for this. That just helps us organize our thoughts. But we're saying that, say that there is such a line that you could draw that is parallel with the other two lines. That allows us to only look at this part on its own first to figure out what this angle is. And then we can look at these two parallel lines, because you can't look at all three of them at the same time as much. It's hard to think about it visually when you try to figure out what this one is. And now you can keep it all drawn together, but again, you're going to have to kind of sort in your head that these two parallel lines are the ones that you're looking at to figure out what that is. So we're going to figure out what W is by looking at the individual parts first. So we're going to use the idea of alternate interior angles to figure out what this is and this is, because this line, this purple line, is parallel with that far right line by definition, by how we had to draw it. Maybe you go through everything to make sure it's parallel. But since they are alternate interior angles, we know that this one must also be 35 degrees. And, same exact idea, we can focus our attention to these two. And to figure out this one, we're going to use alternate interior angles again with that one, because now we are just looking at the left black line and the purple line that I've drawn, and saying it's an auxiliary line or an aux line, and say that these are alternate interior angles. They alternate on the side of the transversal. If you really are confused by this transversal, imagine that it keeps going on forever, that this line segment keeps going on forever, that it has the exact same properties of the original one, but it keeps going forever. So it doesn't really matter how you draw it at all. As you've seen, most of these graphs or these figures are not drawn to scale, and they do all kinds of willy-nilly stuff. So we could actually figure out what the other ones are too. But this one is also 41 degrees because of the fact that they are alternate interior angles for the left black line and the middle purple line that is parallel to it. So that's how we do that. That gave us the angle of E, the measure of E, which is 41, and the measure of F, which is 35. So W has to be both of those added together. 41 plus 35 equals 76. And again, that's because the measure of angle E plus the measure of angle F equals the measure of angle W, which is also given. They kind of walk us through that. And you can see that those are the only two angles present in that angle. So we're looking at minor angles to find out the major angle, I guess. That's some wording that we use in a lot of math, and it could be applied here, sure. So let's go ahead and try to solve these. Okay, so we can use a lot of different things. We just have to tell them what we're using. So if I want to find C, we could easily find C by saying that this is a straight line. Now remember, there are a lot of different methods. We could use corresponding angles to say that this one's 53. It's very easy to say corresponding angles are congruent, so A must be equal to 53. That's the easiest and fastest way to do it. Now, we could also say, all right, well, same side interior angles add up to be 180 degrees. They're supplementary. So C plus A equals 180. C plus 53 equals 180. Subtract 53. C equals 180 minus 53 is, what is that, 27? 10 minus 3 is 7. 8 goes down to 7. Minus 5 is 2. Okay, yeah, I do believe that is 127. 127. If I make a goof, call me out in chat. Whatever. So that's that one. Now, maybe we didn't want to do it that way. Maybe we instead wanted to find it from this. This is a straight line. So we did the last one by realizing that same side interior angles is equal to, add up to be 180, or are supplementary. That's the word we use for that to make it fast. Or you can realize that angles on a straight line, consecutive angles on a straight line add up to be 180 as well. Either way, it doesn't really matter. Right here, you can actually just use the vertical angle theorem and say that this is also 53. These are vertical angles. If you want, you can say that alternate exterior angles are the same. There are so many ways to do these. It's wild, really. Okay, so let's look at this. This one we will likely have to extend some lines, even if it's just for our own sanity. I like doing that, because why not, right? Why not? Oh man, messed up. So I can extend any line segment that I want. So if I really want to, I can just extend all of these if I wanted to find even more out. So we know that these two are parallel, so we get to use that. I can find out a lot of different things. If I want to find out D, I need to figure out what this is, and I can't really do that until I've figured out some more information. So one method of going about this is realizing that you have corresponding angles here, so that's 35. Those are corresponding angles because they correspond to the same side. The same location of, or visually, they're two angles that correspond to how the angles are formed on the parallel line with the transversal. So they're on the same side of the transversal, different parallel lines. But you can kind of look at them and say, and kind of understand the idea of corresponding angles just by sight. And then we'd have to say that these are consecutive angles on a straight line, which add up to be 180. So they're supplementary. So 35 plus D equals 180. Subtract 35 from both sides to get D is equal to 180 minus 35, which I think I did earlier, but whatever. It's 45 degrees, 145 degrees. So 145 degrees. That's what that should be. So that's what I put right there. And I'd say that they are that their corresponding angles are equal in measure, and that linear pairs are supplementary, add up to be 180. Now, I promised you that there were a lot of different ways to do this, so maybe I didn't start that way. Maybe I said this is a vertical angle, right? And then maybe I said that alternate exterior angles are the same. Maybe I figured out what this was by saying that this straight line, for whatever reason, is adds up to be 180, so that's 145, and then this right here is a vertical angle. Maybe I went all over Hell's Half Acre to try to do that. Or maybe there was a better way. Maybe there was an even faster way, or the same at least. We could say that these add up to be 180. Or we could say that these add up to be 180 because they are supplementary, because they are same side interior. So going through the whole process to find out what that would be, we have that, and then say that this is a vertical angle, so it's the same. See how many ways there are to do all these? It's wild. So this one right here, we only have two parallel lines, so watch out for this. We're going to have to split up which ones we're looking at because these are not parallel. These two lines right here are not parallel. So we can't like make a parallelogram out of this. We can't, there's a lot of stuff we can't do. So we have to be very careful with this. And let's look at, I'm going to highlight the ones I want to look at a time. It's not going to straighten out, so I'm going to try again. So we have that, straighten out, there we go, that. Let's look at this one first to find F first, because why not? So looking at what I've highlighted in purple, we know that these are parallel because of those symbols, and we can find a lot of good information here. So one thing that we can do is we can realize that this is a corresponding angle, so this must be 112. Because remember, I'm only looking at what I've kind of marked to myself as the parallel lines and that bottom transversal. We don't want to look at them at the same time. Okay? So, if that's 112, then this has to add up to be 180. So we'll do F plus 112 equals 180. We'll subtract 112 to get F is equal to 68. We could also say that this is 112 as well, because those are vertical angles. We could also say that these are alternate interior angles, so that's 68. And this is a vertical angle with this, so that's 68. Like, once you get started, it's pretty easy to kind of start going and labeling them all. These other ones cause a little bit more of an issue, though. So let's kind of ignore this stuff, because once we found F, that's all they really asked for. So let's kind of get rid of that, and then we'll get rid of that, and we'll go turn our attention to this transversal. All right, so we can use just simple alternate interior angles on these, because we're only looking at the transversal and the parallel lines at this point, this top transversal this time, though, to realize that this is 54, and we're done. There's other ways that we could have done it. We could have done it to where we used other things, but this was actually way easier to do that way. I hope you all agree with that. All right, so maybe let's look at, let's extend this parallel line. And we want to find G, so we want good information with that. We might need an auxiliary line. We might need an aux line on this one. So we've got those two parallel lines. Let's make an aux line. Let's see. Let's just make one of these right here just to see if that helps. So an aux line may very well do that. And again, the way you draw it doesn't matter as long as you're not taking a protractor to these, because these are not drawn to scale at all. They may or may not be. But either way, we've got the parallel lines. We've created an aux line, which again, an auxiliary line, usually we draw it with a dashed little business. We don't have to, but it's just a line that we have created that is defined to be parallel with another line, or defined to be useful, really. So we're going to have to split up G in this case if we want to figure this out. So we can use a couple of facts. A couple of those facts could be just looking on the outside parallel lines. We could actually figure out that this must be 144 because it's an alternate interior angle with this top parallel line, this bottom parallel line, and this. Nope, ignore that. You can't do that. That was my that was a mistake I could have made. That is a common misconception for students. So let's look at one aux line at a time. We've got to extend this one because that's that one line. Let's look at one transversal at a time because that one line right there is not the same. It has to be a straight line with no breaks in it or bends to be a transversal. So it's like we extend one part of that. Does everybody see how I've extended that top part of that line segment that made that between that? So we've extended that top one. Okay? We've extended that top one. And that's important because we don't want to accidentally get different angles from this versus the other one. So we need to figure out what this angle is. This part right here. So we're going to use the fact that consecutive angles on a straight line form a linear pair or more. So we can do 180 minus 144. So whatever the measure of this angle is, we're going to need it if we want to figure out what this is. So that's one method. Another method is that we can say that this angle plus this angle is equal to 180 because these are same side interior angles to this dotted parallel line and this solid parallel line, the aux line and the parallel line. Again, there are so many ways to do this, so don't get freaked out or stressed out because of all the freedom. I'm just showing you a lot of different ways to do it. So far, all I've done is I've kind of made an aux line that is parallel to the other two parallel lines, and I've extended this top transversal to go all the way through to help us. You don't really need to do that. I just do it for so it's visually pleasing for me. But in this case right here, we have this angle, and if I want to figure out what this G is, I need to do 144 plus G equals 180. I feel like this method right here, same side interior adding up to be 180, so they're supplementary. I feel like that is the most direct route. So let's subtract 144 to get G is equal to 36 degrees. It would have given me the exact same thing over here, and that's why the alternate interior angles are the same. And this is right that, there's so much that we can do with this. But let's not get too bogged down with that, with filling out the whole thing. I find it very fun. I find it very difficult to not fill out the rest of it once I've figured out one or two things. So let's look at these at the dotted auxiliary line and the bottom parallel line. We can use alternate interior angles on this one to figure out that these must be the same. They're both 56. I hope everybody sees that. So this entire angle between these must be 36 plus 56, which is 92. Which is 92. That's what G is. It's 92. Okay? Now, let's try looking at something a little spicier. You can extend this to the rest of them if you'd like, but let's look at something a little bit spicier. One that has a whole bunch of, I guess I don't need to get rid of any of that. Except this part. This part needs to go somewhere else. Let's look at this one. I, again, like to start off usually by extending my lines, but this one's one that is way better having an aux line. So what I'm going to do is I'm going to just draw this line and then just move it. That often gives me something that looks way nicer. It even said it was parallel. So I get something that looks a little like that. And if I want to make it look more like an aux line, then I could totally just kind of dash it out a little bit. You guys can use your eraser if you do that. And then, it's parallel to both of those, so let's keep that. And again, I really like extending all of them just to make it look nice. And again, this part right here doesn't really exist anymore because that's part of a separate problem. So let's ignore that, okay? All right, so we can do a lot of really cool things with this. I'm gonna copy this one to kind of make it look like that one. It can't. Do you notice how it's definitely not drawn to scale? Because some of these lines, like this line right here and this line right here, are said to be parallel, but they're definitely not drawn parallel. I tried to move it and it didn't work. Either way, that doesn't matter to us. We're okay with that. But this right here is 162, which means that if we're looking at that top solid line, that leftmost solid line, and the auxiliary line that we have defined to be parallel to it, but it doesn't really exist, then we can actually go ahead and figure out that this angle and this angle have to add up together to be 180, because remember, those are same side interior lines. They add up to, they are supplementary. So 162 plus half of, like part of h, or 162 plus that angle, have to equal 180. So 180 minus 162 is 18. That's how I got that. So that part of h is 18. And we can do something right here with the same side interior angles using the dotted line and the bottommost or rightmost line, and they're both parallel by definition, which means that this right here forms a transversal, just like this one formed a transversal, if I were to draw it properly. So h plus 98 equals 180 because same side interior angles are supplementary. Subtract 98 from both sides to get h equals 180 minus 98. 180 minus 90 is 90, and then 90 minus 8 more is 82. Is that right? Something like that? Yeah. So part of h, it's not h, I'm sorry, I didn't mean to do h. It's this part of h, I don't know what to call it. It's a blank, I'll just use a blank, okay? So that blank right there is 82. I need to watch out for accidentally doing that. Either way, h itself is going to be these two things added up. Both of these angles added up. So it's going to be 18 plus 82 equals h. So h equals 100. That would be your answer there. All right, well, let's do the same thing. We have to use another aux line. So let's see if these are actually parallel real fast. Close enough. Says they're parallel. So I'm going to make an aux line right here. This one looks way better than the last one. And again, I like to dash it out just to know that I invented that line, even though I invented all the purple lines with their extensions and all that kind of stuff. And we know by definition, whenever we call something an aux line, we know it's in this case, we have defined it. We've given it some parameters. We've said, hey, this thing is definitely parallel to the other two parallel lines that we have, so don't worry about it. So we've invented it. There is a line that you could draw there that is parallel to both of those other ones. So we have gone ahead and drawn it. So let's look at the top solid line and the aux line, the auxiliary line. So in this case right here, we can say, all right, well, let's see. These are corresponding angles. So this is 117. And then these both must add up together to be 180. So 117, so what I'm going to call A, I guess, I'll just call it A. A plus 117 equals 180. Subtract 117 to get A equals 63. 63. I believe that is correct. 63. So this part A is 63. I've just decided to call part of my eye A. That's just helping me because you saw the blank stuff that happened a little bit ago. It was very difficult. Variables are just things that are unknown to us, and it's labeling them helps us to organize our thoughts. That's all. And that's that part right there. Okay, so we need to figure out this part right here, which we're going to use the fact that this is a vertical angle right here. You see that vertical angle? It's 129 right here. It's the opposite side of two lines crossing. So that's, again, this transversal. So I'm looking at this transversal now. Before I was looking at this one. I just didn't extend it. You don't really need to. But these two are vertical lines, angles, and that lets us figure out using same side interior that 129 plus this thing I'm going to call B, they are supplemental because they are same side. Both of these are same side interior angles. So subtract 129. And again, this is going to take some practice. 180 minus 129 is going to be 51, I believe. 10 minus 9 is 1. 7 minus 2 is 5. Yes, B is 51. So this entire angle I is equal to the measure of A, that I've invented this letter for A, and this letter for that angle B. That's going to be I. So A was 63, B was 51. Which means I is equal to 114. Now, if I goof, the process is still the same, but I could always have an arithmetic mistake because no one's calling me out right now. Y'all aren't here calling me out. Anyway, so let's look at these a little bit. These look a lot harder, but they're really not going to be that bad. So let's say that we extend this line right here because it's going to be useful to us to do that. Kind of put it up into the spot better. And then we'll use that exact same line to kind of put it right here. And again, you might notice these are not actually drawn to scale. That's terrible. So I'm just going to delete that and try to do it again. Okay, so what can we do? Some things that we can do. We have a transversal right here. If we want to extend this a little bit to look nice. Have a cool little transversal right here. Cool guy transversal here. So this has to be, let's see what we can figure out. Alternate interior alternate interior angles are the same, so that means this one must be 92. So J, easy one. J, 92. Excellent. All right, so if J is 92, and if this is given as 46, do you guys agree that all of the angles on a straight line add up to be 180? Because that's true. All of the angles on a straight line sum to 180. So J plus K plus 46 equal 180. But we know what J is. It's 92. I'm going to change the order a little bit. 46 plus K. That's addition is commutative, so I can change the order. 92 plus 46 is 138, I believe. 90 plus 40 is 130. 2 plus 6 is 8. Add them together, 138. Subtract 138 from both sides to get K is equal to 180 minus 138 is equal to 42. So this must be 42. And again, you can always check your work by adding them all together. 92 plus 42 is 134 plus 46 is 180, I believe. Here's the problem. We're not done. We need to find M. So we need to shift our focus to a different transversal. Now let's look at that transversal. This one's easy. It is an alternate interior angle to M, to 46. So we're done. And that's actually it. This one ended up way easier than I expected. It looked crazy, didn't it? Didn't it look really hard because of all this stuff? Like, look, that's hard. But when you extend the lines a little bit, you get a little bit more information. It's easier to see it as a transversal going through two parallel lines. So let me move this business up there just so I have it. And let's look at this one. I'm going to change colors because I really want to work with teal today. So let's just redraw these. Man. Just redraw these, see if we can do it. One of these days I'll get this drawn. And again, it doesn't have to be perfect. It just has to represent the idea that we want it to represent. They drew this one to where it was pretty much parallel. Excellent. All right, so we'll probably need a transversal for this. Do you guys see how this angle right here doesn't have half of the stuff that we want? So, you know, we could do that. Another thing that we could do that y'all may not have thought about, we could just find out, we could just draw our own transversal through here. But we don't know enough information about that. So let's go ahead and just draw an auxiliary line and say it's parallel. All right, so if we do that, we have a lot of information here. We have alternate interior angles are the same. So again, where you start doesn't matter. It's just what you notice first, all right? So those two for the top parallel line with the auxiliary line, the aux line, we know that we have alternate interior angles right there, which is really helpful. So that's one way to do it. Let's see if there was another way. We really only need to look at in, now that I think about it. So corresponding angles, this is a corresponding angle with 37. We didn't really need to find that out, but that's a corresponding angle with 37. Corresponding angles, remember, they correspond to the same location. Because I'm looking at this transversal right now. If you're not with me, I'm looking at this transversal. I'm going to highlight it to try to make it to where it makes more sense. So do you see that? We're looking at that transversal right there. We're looking at these two right here. These become a little bit more difficult because you have to make an aux line, and then you have to you have to kind of look at the transversal that you care about. So sometimes being able to write directly on it or use your scratch paper is really helpful. But now it's easier to see that this and this are corresponding angles, is it not? Because they correspond to the same side of the transversal, but opposite parallel lines. Or you can say that they that visually they correspond with one another. But either way, that's 37. Now let's shift our attention away from that and look at the other transversal, because we need to figure out what this part is. And we can only do that because we have to figure out a way to use that to find the angle. So again, this right here and this right here are corresponding angles, so this must be 44. Because we're looking at these two parallel lines now, and that middle transversal that I put in green. So since those are corresponding angles, they are congruent. So now to find in, we really just need to add them together. 44 plus 37 equals the measure of angle n. 44 plus 37 is 70, 81. The measure of angle n is a way to write that. 7 plus 4 is 11. 40 plus 30 is 70. 70 plus 11 is 81. That's how I got that with quick maths. So this is a very similar thing. I think for these last two, they're pretty rough. I might make a separate video if you guys request it. We have the problem set as well. I may make a separate video if you guys request it, but I want to show you that this is not very hard. This is the same idea. It looks spicy. That's the real problem. We have a parallel line right there with this one. Do you guys notice how they have different symbols? How one of them has two little notches to say that those two are parallel. It has this twice to say that that parallel line goes with that one. And these two parallel lines, I'm going to draw in a different color because that can also help if you don't want to keep it like that, you know, maybe I draw them separately. Boop, boop. So those two go with each other. I'm going to color code each one of them. And my transversal, I'm going to go ahead and make it purple, because why not? Nobody said it had to be one thing or another. So you've got two sets of parallel lines with a single transversal that goes through them all. So let's look at our red ones first, because our red ones are super important right now. Because this 94 degrees it comes from the angle of the first notched parallel lines, the red ones, and the purple transversal. So 94, we know what that is. We need to figure out Q. Well, to figure out Q, we realize that on those two, on the red parallel lines and the transversal that goes between them, those are corresponding angles. Do you see that? Just ignoring everything else and just looking at the red parallel lines and that purple transversal going through those parallel lines, it's like the other set of parallel lines doesn't exist. So Q is 94. What's interesting about that is we need to figure out what this is a little bit more to be able to figure out what P is over here. Because if we can't, we realize that this and this are actually the same, but we don't really know that just yet, but we're going to find out. That's one way to do it. Or, if you would rather, you could ignore this teal line right here and realize that this plus that Q have to add together. Ignore the teal lines, okay? Pretend they're not there. Just look at the red lines that are parallel and the transversal, the purple transversal. This thing, this entire angle right here, not P and not this part on its own, the entirety of this to the transversal, what added to this will be 180. So this entire thing is 180 minus 94, which is 86. That whole thing is 86. So let's stop looking at our red lines for right now. Because we can't find P, we just want to use what they've given. So 68 is this one. Let's look at our teal lines now. So let's ignore this part. We don't need the red lines anymore. Let's just look at our teal lines hitting that transversal. Notice this is 68. But notice this part, not the entire 86 that we figured out a little bit ago. This part that goes from the teal parallel line to the transversal, that part right there is a corresponding angle with the 68 degrees. This corresponds with this. It's hard to see. I'm going to erase it temporarily. But this part right here is 68. Now this whole thing is, what did I say it was? 86? That whole thing is 86. But this part right here is 68 because that part right there is a corresponding angle with this. You can see it when you're looking at it, but all the other stuff is very confusing. It's a visual confusion. So be careful. So this entire thing from the transversal all the way back to our red line was, our original red line was 86, and this part of it is 68. So we know that P plus 68 equals 86. So let's subtract 68 from both sides to get P is equal to 14. So this part right here is 14. And we are actually done with this one. Now, if I goofed up some arithmetic, please let me know. Arithmetic is not true math. It's the results of math using algebra on the number one in a weird way. It's called ciphering. So, do we really want to do this? Yeah, let's go ahead. Let's see if we can get this easily. So this one might require a lot of little auxiliary lines and extensions, just to help us visually. So let me go ahead and extend a couple things. Let's see what we need. Let's extend this a little bit further. All right, maybe that helps. Who knows? Let's see if just drawing it like that to help us out, if that actually helps us. Because R doesn't look like it actually has anything helpful over there. So extending it that far really didn't help us. So let's try extending this one and seeing if that helps us. It could still help us. So let's just do a different color for each one of these. Sometimes I like just doing that. We might just need an auxiliary line. So that right there is that transversal. And then I'll change the color of this to a teal again. And let's go ahead and grab this and go ahead and make ourselves an auxiliary line because we might need it. There's a lot of stuff going on, but color coding it often helps. So let's make an auxiliary line to see if we can figure this out really fast. We might be able to. So those three purple lines are all parallel to one another. So what's cool about this is that this part right here, these are alternate interior angles. So R is the same. So that's also R right there. That may or may not help us. We're going to find out. Well, we know that this right here is 130 degrees because this is an alternate these are corresponding angles with one another. If we look at the purple lines, the top purple line and the bottom purple line and the red line. So we could say that that's that. That might help. And we can figure out this part. Do you see how we can figure out this part of that angle? We actually didn't need almost any of the top parts to figure this out. So right here, remembering that same side interior angles, looking at this dotted line right here and this solid line right here, same side interior angles are both of these added together, and they're supplementary, so they add together to be 96 plus 130 equals 180 somehow. Not 96, I'm sorry. We got to call it like A or something. I keep doing that. We got to call this like A. This part, because this whole thing is 96. This part is something we don't know yet. So A, let's just use a letter for it, because why not? A plus 130 is equal to 180. Subtract 130. A is equal to 50. A. So A is equal to 50. Now we need to figure out what R is. Well, that's easy. I don't need the auxiliary line quite as much anymore, because this entire angle, right? This entire angle include so A plus R is equal to 96. So A plus R equals 96. We know what A is. It's 50. Subtract 50 from both sides to get R is equal to 46. R equals 46. Excellent! Great job, everybody. Now, what's interesting about that is we can actually go right here to see what the right answer is. And I never ended up doing it. But let's see what's... Hey! We did it right. All right. And we've got 18 and 94 right there. I might have messed up my arithmetic a little bit with the same idea. But there's the reasoning. And honestly, I'm not assessing you for a grade on this, so I don't mind you seeing that a little bit. As long as you don't give me that when you're actively working on it in class, you're good. Alternate interior angles. Here are the official definitions of this. So if you want to pause and look at the relevant vocabulary, it's in your book as well. But it's a good idea to actually be able to word it like this. Kind of make sure you're understanding the wording itself. Anyway, y'all have a fantastic